The region below is bounded by y equals 3 root x, y equals 0, and x equals 9. So here's the region. And then it says the region is rotated about the vertical line x equals 13. So this is where things change. Now we're not rotating about the x-axis or the y-axis, but about a particular line, x equals 13. Using washers, find the volume. Um, so what I did is I drew the line x equals 13, right? That goes through the x-axis. This is the x-axis, as you know. That goes through the x-axis at 13, that dotted line. And then we're going to rotate, see my little rotation symbol up there, about that line. What's going to happen? Well, it's going to, this thing's going to go over there. We're going to have these discs that basically, they end up looking like this. Don't they? And then they're going to have an inner piece like that. So we're going to have these discs, and they'll have a little bit of thickness to them. See if I can risk just a little more drawing. Oh, I was so close to. There we go. Yeah, so there we go. There's our little washers. There's our little washers that we're going to use to fill up the shape. Right? We're going to fill up the shape that way. And you can see that. I went to the three-dimensional Desmos grapher. And here's what it's going to look like. It's a little different because I turned it. So here's the x-axis, here's the y, just so you could see it better, right? So I turned the whole thing. So can you picture that, right? Here's the x. It's been turned to here. The y has been turned to there. And so there's the shape that'll come back. We're going to have these washers, and they'll get tinier and tinier and tinier. So they get tiny near as you go up the y-axis, up the y-axis. They get tiny, tiny, tinier, right? They start out big back here at x equals 0. Okay. Now here it is. I turned around the back side. So X and Y like that. And you can see the washer, the back of the washer very clearly. That's going to be this bottom washer right here, is this one. So, all right, so let's do the integral. So a bunch of washers. You know how to do this. The volume of each washer. Volume of each washer is pi big R squared minus pi little r squared, then times the thickness. Right? Like the volume of that washer. How much volume, three-dimensional volume is there in that washer? Well, first off, they're asking, are we going to integrate dx or dy? Well, the thickness always tells us that, right? And so how are they stacking up? How are they stacking up? The thickness is right here, huh? Let me change the color on that. So the thickness is dy. That's how thick it is, huh? It's going up and down. The thickness is up and down, like the y-axis up and down. That's why this is dy. Okay, so thickness is dy. Got that. Now we need the inner and outer radius. Okay, so here we have the inner radius. Put that on there. Try to change the color here. From there to there. That's the little inner radius. Okay, now what is that little inner radius? Well, it looks like it's always the same. It's how far from here to here, which is what, 13 to 17. Or you could go back the other way. Probably easier actually to go back the other way. Let's do that. So I'm going to say you could just go back that way. There's a little inner radius. It's how far from 13 back to 9? It's 4. The little radius is 4. You can see that. The little inner radius is 4. All right. Now, what's the outer radius? How far is it from here all the way back to there? That's the outer radius of each of those washers. How far is that? Well, that's more tricky because that's going to hit this curve y equals 3 square root of x. Good job. Right? So how far is it to there. Well, got to be a little careful here. Let's think carefully about this. We know how far from there to there is x equals 1/9 y squared because what did I do there? I took this equation, let me just scribble it over here. I took the y equals 3 square root of x and I solved for x. So square both sides. Y squared is 9 and the square removes the root. X divided by 9. There it is. X is y squared over 9. So, or 1/9 y squared. So that, remember, the x is how far from the axis over to any point on the function. So this x distance right there is 1/9 y squared. Whoops. It's 1/9 y squared. So, I want to make this a little more clear here. Right there to there. That's 1/9 y squared. Okay. And I know the whole distance. Let's learn that all the way is 13, clearly, because we're hitting the line 13. So therefore, how do we find the big R? Take the whole 13, subtract that. Do you see that? That's where it gets a little tricky. Big R is 13, take away 1/9 y squared. Right? Because the whole distance is 13. This little part is 1/9 y squared. So then the big R is the difference. You see that? So one more time, the whole radius is 13. This little x value is 1/9 y squared, right? So if you take the whole distance, subtract the distance to the curve, you get the big R, which is the outer radius of the washer. So it's 13 minus 1/9 y squared. So that's going to be pi times 13 minus 1/9 y squared, right? That big R goes right there, times the thickness, which we already said is dy. Okay, we're going to integrate that. We're going to integrate that from y. It's a y integral, right? It's dy. From y equals something to y equals something. The bottom to the top. What's the bottom? Well, the 0 is the bottom. We're going to stack up those washers. And what's the top? Up here, it looks like 9. Up is y equals 9. 0 to 9. And that's what it is. 0 to 9. They have 13 minus y squared over 9 squared minus 16. They just put the pi in the front. And we know it's dy. And so there we go. We can see it here. It's the outer radius and the inner radius on that three-dimensional picture. So there we go.